Hi, I'm Byron from CanScale. CanScale is an initiative to build a suite of scalable infrastructure tools for the Internet computer. Today, I'm going to talk to you about scaling on the Internet computer with CanDB, a NoSQL database built specifically for the Internet computer. In this video, you'll get some context on why the Internet computer needs a generic and scalable solution for data storage. You'll also see a demo live on the Internet computer in which CanDB has been used to store over 4 million comments from Reddit. We'll then also talk about the CanDB Roadmap and cap things off with a special announcement of things to come for CanDB. So why do we need a scalable data storage solution? Well, on the Internet computer, canisters are the unit of computation and data storage, and they're bounded to a heap size limit of 4 gigabytes. After reaching this limit, a canister will become unresponsive. This has implications also when upgrading a canister, in which a canister with more than 2 gigabytes can potentially overflow their heap and fail during upgrades. And the Internet computer does not provide automatic scaling out of the box for its canisters. So I'd like to reiterate that. The Internet computer does not have a generic, multi-canister, performant, and scalable data storage solution. And developers coming to the Internet computer from other cloud providers already have experience with scaling out their applications. These developers expect ready-to-go services and databases that facilitate scaling, like MongoDB, Apache Cassandra, and Amazon DynamoDB. So the current landscape of storing data on the Internet computer falls into one of two buckets. One could be categorized as big map type proof of concepts. A little bit of background, the Big Map project was advertised before the main network launch as it was going to be the go-to auto-scaling solution that would allow developers to scale out their canisters with their data needs. However, it was not launched with the main network launch and still has not been launched to this very day. So there are a few proof of concepts that have sort of riffed off of Big Map that do provide auto-scaling multi-canister solutions. However, these solutions are not sufficiently generic. They're simple key value storage. So they're great for CDNs, but also other solutions rely on frequent inter-canister calls, which are also not performant. And then the other main tool that people use to store data on the Internet computer is the SQL database, SudoDB. While extremely flexible generic, it's limited to a single canister at the moment, and will have major difficulties scaling performantly due to some properties of SQL, such as data normalization and uniqueness constraints, which require joins, meaning inter-canister calls are required for a SQL solution. There are many complexities involved with building out auto-scaling solutions on the Internet computer, and for this reason, teams are delaying scaling for as long as possible. In fact, many large projects on the Internet computer have the majority of their application housed in a single canister. Maintaining a single canister application that is close to its storage limits can end up becoming much more difficult, time-consuming, and costly than just migrating to a scalable solution. Imagine you're an entrepreneur building the next big application on the Internet computer, and you've realized that you need to build out an auto-scaling storage solution, and you're investing time and resources building the solution custom to your application that could be spent building your application instead. This problem isn't unique to your application, and these costs are repeated across projects, slowing the progression and the overall growth of development on the IC. So now that we've talked exhaustively about the problem, I'd like to introduce the solution, CanDB. CanDB is a flexible, performant, and horizontally scalable, non-relational, multi-canister database built for the Internet computer. It's written in Motoko. It has a familiar NoSQL API to DynamoDB or MongoDB, which allows for direct and range-sorted lookups. It also abstracts and automates the scale and complexity of dealing with data partitioned amongst multiple canisters, and ensures that your data is persisted through canister upgrades. So if you look at this diagram, you can see three main components of CanDB. The first, over on the right-hand side, is CanDB data storage, or the canister storage partitions. In each of these partitions, a CanDB data structure stores data within a canister and allows for flexible and performant CRUD operations. If we look right above the client, we see the CanDB indexing canister. This canister holds information mapping data partition keys to storage partitions. It's also responsible for scaling out the storage partitions on the right. And the final component is the CanDB client. This piece of software provides an abstraction through which communication between the client and both the indexing and storage canisters takes place. The client's responsible for coordinating both query and update calls using the index canister to ensure that the request makes it to the right storage canister destination. Here we have the original architecture for BigMap, which follows a similar implementation. I like to think that the creator of BigMap knew some of these limitations of the IC involving inter-canister calls, so they opted for a more client-heavy design. Developers can integrate each of the components of CanDB into their application in 3 simple steps. First, they add the backend CanDB package dependency to a project. Second, you set up your storage partition actors like you would in a normal application, and then you use the CanDB library to help set up your index canister manager actor. And third, you import and hook up the CanDB client library into your client-side application. This library is currently in TypeScript, but there are plans to build CanDB libraries for other languages as well in the future. Before going into the demo, let's take a brief look at the CanDB documentation. The CanDB module is an interface on top of what I'm calling a range tree, which is essentially a red-black tree. This provides normal CRUD operations that you'd find in a database. We see here get, we see put, delete, but it also provides the scan operation, which is an enhancement that allows developers to use pagination. Inside CanDB, we store records in what's called an entity, which consists of a primary key, a sort key, and then an attribute map, which is essentially a mapping of attributes. Each of the attributes stored in CanDB are stable to guarantee that all data stored in CanDB persists through canister upgrades. On the client side, very briefly, this is how you set up a client to interact with your index canister. And this is how you set up a client to interact with any of your actor canisters, passing in the index client that you just instantiated. Through the actor client, you can do things like query, update, and even reduce the queries since they'll be hitting multiple canisters. I'd now like to showcase you my demo application using CanDB. This application is hosted on the Internet Computer and utilizes the Reddit COVID dataset, which contains all the mentions of COVID-19 on Reddit up to the 25th of October, this most previous year, 2021. It's about 12.6 gigabytes. And what I do is I took a subsection of that data, about 2.85 gigabytes, and I've uploaded it to the Internet Computer to see if we can do things like query by the upvote score, the subreddit, and the timestamp. You can think about this as like a top votes, get by subreddit, latest by subreddit, and query by latest timestamp type of post, newest posts. So what we can do is we can get the comments, and what this does is this is going to return over all of the subreddits between these two dates, gigabytes and gigabytes of data, the upvoted count, and it's going to be all sorted in order. And we can see right here, this next page, this uses the next key below. So this is the sort key that's being used to essentially order this data. So if we click on the next page, we'll get the next page of results. And what we can do is, we can also do something like we can take this or, take this subreddit and we can put it in and we can query by subreddit, and we're going to get the latest comments for this specific subreddit, the 24th, right? We can also change the date range in here, so we can go from August to September, and you'll see that these times are, local to me, so it might be different. You might see something different based on your time zone, but if we query here, now we're going to get stuff from September 14th going backwards. Similar thing if we want to do a score query between this. Now we're going to get the top score between these two dates. And then we can also just get the latest overall between these two dates. So it's a pretty neat little tool, and it's pretty performant considering that now if we go to the monitoring tab and we look at get canister metrics, we can see that this application now has 149 canisters that we've spun up to store all of this data. And this data is all ordered by partition key, which is by date. So we can see that each of the canisters stored in a specific date. We can see the auto scaling status, so we can see which canisters have scaled out and which have not scaled. We can see the heap utilization, the entity count, and the cycles remaining. And these queries are all done as well using CanDB. So now using what we know, we can go back to the comments, and we know that each of these queries, if we see timestamp or score, we can celebrate that the performance does not go down as we scale out with more canisters, and that the client is able to handle this load. This is even more impressive considering that I'm not just storing 2.85 gigabytes, I'm storing close to 8 gigabytes worth of data. Since in CanDB, I created the equivalent of 2 secondary indexes that replicate each comment. So it's really a 3x on the data stored on the internet computer. With scalable infrastructure tools like CanDB, we can start to see the big picture of what the future of the IC looks like. It's not just in decentralized assets. It's in decentralized communication, whether it be social fi or games as well. Developers can now build on this architecture to construct composable and scalable microservices with CanDB canister clusters. As your application grows, scaling horizontally with CanDB yields consistent performance, and a shallow client-centric architecture allows you to move faster and is less brittle to changes in canister APIs. Developers can be empowered by CanDB to perform rolling upgrades to their microservice clusters without affecting other services, and developers can build and open source their own CanDB microservices. To both recap and go into the complete list of features that CanDB currently supports, we have performant query and update calls, as well as CRUD and scan type of APIs. CanDB also guarantees the stability of your data and it persisting through upgrades. CanDB also provides APIs that allows you to control when your canister auto scales. It also provides APIs for rolling upgrades and targeted canister deletion, as well as the client SDK for interacting with both the indexing canister and your canister microservices. It brings me great joy to say that the CanDB project has been able to deliver on every milestone thus far, including this most recent milestone for Supernova. Going forward, this is what the CanDB Roadmap looks like for Q3. Starting a closed alpha for 10 to 20 developers, and really doing a lot of stress and chaos testing with CanDB and the internet computer in general, so that performance metrics can be published to give developers confidence when they're building out their applications on the internet computer. Sometime between Q3 and Q4, I hope to end the alpha testing phase for CanDB, add a few additional much desired features, and start the open beta. So this is sort of my surprise announcement. If you can't wait until 2023, come alpha test CanDB with me. A little bit about myself. My name is Byron Becker. I'm from the San Francisco Bay Area. You can see this is my contact information for where you can find me on the developer forums, Twitter, and the developer Discord. And what I'm really looking for are 10 to 20 projects on the Internet Computer that are either handling large amounts of data or plan to in the future. And I really want to be working with active teams that have the bandwidth and desire to build massive, scalable, decentralized applications on the Internet Computer. This is a little bit of my career experience. I worked at startups in the past, as well as I worked on a co-development with BlackBerry while I was at AWS, building out cloud infrastructure for the next generation of connected vehicles. So I'm really excited to hopefully be working with you, and please reach out to me at any of these handles if you're interested. Thank you for your time.